Okay, here we go. Lesson 1, Unit 6. We're on to coordinate geometry. So let's try transformations with coordinates. Traversing the plane, you got a point A, point B, you got your X and your Y. How far is point A from point B? Well, here's how you do these. You just draw a right triangle for now. There's a distance formula we're going to get to, but for now, just draw a right triangle. Label your legs, 3 and 4. So A to B is 5. I know that because 3, 4, 5 is a Pythagorean triple. Or in other words, 3 squared plus 4 squared equals AB squared, right? Pythagorean. 9 plus 16 equals AB squared. 25 equals AB squared. Square root both sides. AB equals 5. If you know 3, 4, 5, if you see a right triangle with 3 and 4 for the legs, you automatically know the hypotenuse is 5. But anyway, AB equals 5. Which transformations will take point A to point B? Well, remember you got translations, rotations, and reflections. Those are the rigid transformations, and then you also have dilations. Those are for similarity. But what transformations will take point A to B? Well, you could just translate via directed line segment. In this case, it would just be AB. You could also translate A 3 units down, 4 units to the right. That's another one. Or how about 4 units to the right, 3 units down? Let's see, what else could you do? Let's just keep it there. So there's some complex rotations, reflections that you could do, but let's just keep it simple. Translate it, directed line segment AB, or just translate it 3 units down, 4 to the right, or 4 to the right, 3 units down. That'll get from A to B. All right, first question down in Unit 6. 1.2, transforming with coordinates. It's here on page 7. So first, predict where each transformation will land, and then next, carry out the transformation. All right. So I don't know what that means until I read number 1. Number 1 says rotate figure H clockwise, so I know it's going this direction, using center 2, 0, 90 degrees. Okay. Then you got to translate that image by a directed line segment from 2, 0 to 3, negative 4, and label the result R. Huh? That's what I'm thinking, but it's really not that hard. Use patty paper. That's the key on this one, patty paper. So, here we go. Got mine right here. So let me trace H. All right, so there's H. So first thing we got to do is rotate figure H clockwise using center 2, 0, which is right here, 90 degrees. So it's going to land right here. That's going to be our first move, our rotation. Then I got to translate this image by directed line segment from 2, 0, there's 2, 0, to 3, negative 4. there's 3, negative 4. So I gotta move every point. Make sure this 2, 0 goes to 3, negative 4, which is right there. See, 3, negative 4. So we were here, and we just moved it to 3, negative 4. The key is to get the points. This is the hard part. You keep your finger where it is, your left hand, for me anyway, and then you plot these points. So you know 3, negative 4 is going to be one of them. 3, negative 4. And then you know 5, negative 4 is going to be one. All right, and then you know 3, negative 6 is going to be one. And then also 6, negative 6. And you got to label the result R. All right, so use patty paper. That's the key. Okay, reflect figure H across the y-axis. So here's H. You gotta this is number 2. So you gotta reflect it across the y-axis. So remember, reflection goes like this. It's like a mirror. Then we gotta rotate the image counterclockwise using center 0, 0. Well, here's 0, 0, so you put your pen on 0, 0. And we're going counterclockwise 90 degrees. So you got 0, negative 2. 0, negative 2. You've got negative 2, negative 2. You've got negative 3, negative 4. And you have 0, negative 4. Those are your 4 points. Connect the dots. And we gotta label it L. All right. Once you label these both, I'll know you will have done the moves. And you need patty paper. So if you want to take some home with you to do the homework, not a bad idea. All right, number 1.3, congruent by coordinates. Here we go. Calculate the length of each side in triangles ABC and DEF, okay? AB is 3, right? 5 minus 2 is 3. CB is 3 minus 1, or 2. We'll figure out AC in a minute. ED is also 3, and EF is 2. You got right triangles because we're on the coordinate plane, meaning that 3 squared plus 2 squared will equal AC squared. So 9 plus 4 equals AC squared. So 13 equals AC squared. So AC will equal the square root of 13. So this is the square root of 13. Now I could do that all over again, but it's going to be the same answer. So this one is the square root of 13. And you've calculated the length of each. Now calculate the measure of each angle. Okay, so we already have the 90s, right? Let's shoot for A. And remember, we're going to use trig ratios. So for A, 2 is opposite, 3 is adjacent. So then you can say tangent of angle A equals opposite over adjacent. Don't forget SOHCAHTOA, you already know that. That's how you find angle measures using the legs, the length of the legs. So tangent of A will equal 2 divided by 3. So tangent of A equals 0.667 So once you get here, tangent of A equals 0.667. To find the measure of angle A, that will equal the inverse tan of 0.667. So the measure of angle A will equal second tan 0.667, 33.7. So we're going to call this 34 degrees. So angle A equals 34 degrees. That means angle D is going to be the same, 34 degrees. The reason I know that is because we have a 2, a 3, and a square root of 13. A 2, a 3, and a square root of 13, meaning triangle ABC and triangle DEF are congruent by side, side, side triangle congruence theorem. So angle A and angle D will both be 34. This one, C, will be congruent to F. That'll be 90 minus 34, which is 56. Got the measures of each angle. The triangles are congruent, number 3. How do you know this is true? Side, 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 triangle congruence theorem. Tells us the triangles are congruent. And what does that mean? Well, you got a 2, a 3, and a square root of 13. So because you have a 2, a 3, and a square root of 13, a 2, a 3, a square root of 13, those triangles are congruent by side, side, side. Because the triangles are congruent, there must be a sequence of rigid motions that takes one to the other. Find a sequence of rigid motions takes ABC to DEF. So ABC to DEF. Again, use patty paper if you're stuck on this. So let me just trace ABC. There's A, there's B, there's C. Straight edge would be better, but I'm trying to do these videos. So I always recommend going, A and D are going to correspond. So translate A to D. And you at least have 2 points that match up. So A goes to D, right? Let me just see. You could rotate. It's not going to help you. Let me see. Translate A to D. You could reflect. Rotate. Reflect. That would work. Or how about this? Reflect over the y-axis. Translate A to D. Rotate. And reflect again. There's gotta be an easier way. Let me see. Oh, what if you rotate? Translate. That would work. There's an infinite number of ways, but it looks like the easiest way is a rotation. 90 degrees counterclockwise, center A, and then translate A to D. So, translate A to D. Oh, there it is. Rotate. Duh, silly me. So translate A to D. Rotate 90 degrees. counterclockwise. Translate A to D. Rotate center D 90 degrees counterclockwise. Play with that with the patty paper. There's a number of different ways that would work, and that is lesson 1.